Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 14. So this week was all about operations with fractions, adding, subtracting, multiplying, and dividing fractions. So let's start with addition and subtraction. Now, this is a little tricky. The reason is you can only add or subtract fractions when they have the same denominator or same bottom numbers. If they don't have the same denominator, you actually need to use equivalent fractions to make them have the same denominator. So let's start with 3/8 plus 1/8, and we'll illustrate it on that pizza here. So if you have 3/8 of the pizza, each of these slices is 1/8, so you would have 3 slices. So 3/8 is this much pizza. Now, if I add another eighth to this, if you get another slice, you now have 4 slices. You have 4/8 of a pizza. So notice here, when I added these fractions, the denominator did not change. If you have 3 of something and you add 1 more of that something, you now have 4 of that something. 3/8 plus 1/8 gives you 4/8. So we only ever add or subtract the numerators. We never change the denominators when adding or subtracting fractions. So sometimes when you get an answer, you may need to simplify it. You know 4/8 is a half. I've actually colored in half the pizza. So my final answer here is a half, and I'm done. Let's look at this question here. This one's a little more tricky because the two fractions have different denominators. So what we're going to do is exactly what we did when we were comparing fractions. When we had two fractions and we wanted to decide which one was bigger, we could only compare them when their denominators were the same. So what we did was we found the lowest common multiple of the denominators. Now, the lowest common multiple of 3 and 15 is 15. 15 is the lowest number divisible by both of these numbers. So what we do is we make both fractions have denominator 15. Well, this one already has a denominator 15. I leave it as it is. How am I going to make this one have denominator 15? Well, to go from 3 to 15, I need to times by 5. But what you do to the bottom, you must do to the top. What I'm doing is I'm finding an equivalent fraction of a third. So 1 times 5 is, of course, 5. 3 times 5 is 15. Turns out a third and 5 over 15 are exactly the same. They're equivalent fractions. So now, instead of doing a third plus 4 over 15, I do 5 over 15 plus 4 over 15. Gives me 9 over 15. Once again, I only added the top numbers. I left the denominator the same. So check your answer and see if you need to simplify. I need to simplify this. How do I know that this can be simplified? Because 9 and 15 have a common factor. Their common factor is 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. So a third plus 4 over 15 is actually 3/5. So I know it gets a bit tricky. We use lowest common multiple to find equivalent fractions, and we use highest common factor when simplifying. So let's look at this one here. So two different denominators. We need to find their lowest common multiple. So the lowest common multiple of 9 and 4 is 36. So I need to make each denominator 36. So I need to times this one by 4 to get to 36. What I do to the bottom, I must do to the top. To go from 4 to 36, I need to times the bottom by 9. What I do to the bottom, I must do to the top. Again, the reason I chose 36, chose to make this one and this one have denominator 36 is because it's the lowest common multiple of 9 and 4. So 8 over 9 is the same as 32 over 36, and 3/4 is 27 over 36. So when you're subtracting fractions, you do pretty much the same as adding, except instead of going 32 plus 27, I go 32 minus 27 is 5. Once again, I leave the denominator alone, and that's my final answer, 5 over 36. This one can't be simplified because 5 and 36 have no common factors other than 1. Let's now look at multiplication. So multiplication of fractions tends to be a lot easier. It's because this line in a fraction means divide, and division goes with multiplication much better than division goes with addition or subtraction. So when you're multiplying two fractions, you just multiply the two numerators, so 7 times 3 is 21, and multiply denominators, 10 times 5 is 50. So the biggest mistake I see is that people think you can only multiply fractions when they have the same denominator. We don't make denominators equal for multiplying. We can multiply fractions even if they have different denominators. It's just because multiplication goes with division. So how do we do something like this? Well, if we wanted to do 56 times 44, that would take a while. Surely there's an easier way. So what you can do is use cancelling. You can cancel any common factors. So let's see 33 and 44. They both have a common factor of 11. So I can divide 33 by 11 and I divide 44 by 11. That's okay, as long as what I do to the top, I do to the bottom. 7 and 56 also have a common factor of 7. 7 divided 7 is 1. 56 divided 7 is 8. So why did I cancel? Well, now instead of doing 56 times 44, I only have to do 8 times 4, which is much, much easier, particularly when we don't have a calculator. So the answer I get is just 3 times 1, which is 3, and on the bottom 8 times 4, which is 32. So much simpler after we cancelled. So let's look at 5/9 of 54. Now, of means multiply. So this is 5/9 times 54. Now, how do you multiply a fraction by a whole number? Well, you just write the whole number over 1. 54 and 54 over 1 are equivalent. They are exactly the same thing. So doing 5 times 54 is a little difficult. Let's try and cancel. 54 and 9 have a common factor of 9. 9 divided by 9 is 1. 54 divided by 9 is 6. That just makes it so much easier. Instead of doing 5 times 54, we're doing 5 times 6. You can cancel anything on the top with anything on the bottom as long as they have common factors. So now I just get 5 times 6 is 30. 1 times 1 is 1, but I don't really need to write that. 30 over 1 is the same as 30. So it's much simpler to just write 30. And then we're done. All right, let's now look at division. So when you're dividing fractions, you multiply by the reciprocal, and the reciprocal is just the fraction flipped. So this means if I want to perform a division of fractions like this, what I do is I always leave the first fraction the same. I flip the second fraction, and I change the divide to a times. So now we know how to multiply. This is really simple. We just go 5 times 11 is 55, 12 times 8 is 96. So we can't simplify this any further. 55 and 96 have no common factors. So what about 7 divided by 2? Well, on the previous slide, I said if you have a whole number, you just write it over 1. 7 and 7 over 1 are the same thing. So I have 7 is equal to 7 over 1. I haven't changed the first number. But what I do is I take the second fraction and I flip it and I change the divide to a times. So now I've got 7 times 2 is 14. 1 times 1 is 1. Again, I don't really need to write 14 over 1 because 14 is simpler. So a lot of people think 7 divided by a half would be 3.5. Well, no, 7 times a half equals 3.5, but 7 divided by a half is saying how many times does a half go into 7? Well, a half goes into 1 twice, it goes into 2 4 times, 3 6 times, and so on. A half goes into 7 14 times. That's why that's the answer. All right, let's now look at some worded problems. So here we have 2 worded problems, and I know worded problems can get confusing, but really these are just about using operations with fractions. So let's say my team plays 32 matches in a season, they win 5/8 of them. How many matches have they won? Well, let's decide the operation we're using. We're just really being asked in this question, what is 5/8 of 32? But you know from previous slide that of just means times, and when we're timesing by a whole number, we just write it over 1. So instead of doing 5 times 32, which takes a while, look for common factors, try to cancel. 32 and 8 have a common factor. 8 divided by 8 is 1, 32 divided by 8 is 4, so I'm just left with 5 times 4 is 20. On the bottom is 1 times 1, but I don't really need to write that. So if my team wins 5/8 of their 32 matches, they will have won 20 matches. 20 is 5/8 of 32. So let's try this question down here. In a class, each student has blue, green, or brown eyes. 5/6 have blue eyes. 1/10 of students have brown eyes. What fraction have green eyes? Well, let's first figure out what fraction of students have blue or brown eyes, because a student can't have both. So the fraction that have blue eyes plus the fraction that have brown eyes. Now, to add these two fractions, I need to change their denominators. You can multiply fractions even if their denominators are different, but to add fractions, denominators must be the same. So since the denominators are different, I find the lowest common multiple of 6 and 10. So that's 30. So I need to times 6 by 5 to get to 30. What you do to the bottom, you must do to the top. To get to 30, I need to times 10 by 3. What you do to the bottom, you must do to the top. So it turns out 5/6 is the same as 25 over 30. 1 over 10 is the same as 3 over 30. So if I add these together, I get 28 over 30. 28/30ths of the class have blue or brown eyes. And of course, this simplifies to 14 over 15 because 28 and 30 have a common factor of 2. 28 divided 2 is 14, 30 divided 2 is 15. So that's the fraction that have blue or brown eyes. So what fraction would have green eyes? Well, that would be 1 whole. The class is 1 whole. Subtract 14 over 15. If 14/15ths of the class have blue or brown eyes, there's 1/15th left that would have green eyes. So how did I get 1 over 15? Well, if you're stuck with this, remember 1 whole is like 15 over 15. It's 15/15ths. So here, I've written 1 as an equivalent fraction, 15 over 15, subtracted the numerators, and I keep the denominator the same. And that's my final answer. 1/15th of the class has green eyes. All right, thank you so much for tuning into this video. I know we're going really fast, but keep your head up. I'm so proud of the class and the way you're going. This has been the luckiest maths teacher in the world. Have a great day.